Today we're going to be discussing the Pythagorean Theorem. And the Pythagorean Theorem is a proof related to right triangles like we discovered yesterday. And to know that you've got a right triangle, the right triangle always has a 90-degree angle. And the parts of a right triangle are labeled according to the Pythagorean Theorem. The right triangle is made by perpendicular sides, A and B, and then the diagonal in the triangle is called C. So now the next question is, what and where is the hypotenuse? Because not only are the parts of a right triangle labeled A, B, and C, but they also have names. And so if you look down here at your triangle, you're going to see there's your right angle, there's the two perpendicular sides. Both of the sides that form the right angles are called legs. And legs are interchangeable. So in other words, what that means is it doesn't matter if you label the bottom A and B or the top A and B. Doesn't matter if this one's A and this one's B or vice versa. You could change them either way like we did at the top. What's important is the hypotenuse. And the hypotenuse, there's two things to remember about that. It's always the largest measurement. So of the three numbers, it's going to be the biggest. And remember, Pythagorean theorem has to do with distance. So it's going to be the longest distance or the largest measurement. And then it's always going to be across, the hypotenuse is always across from the right angle. So if you locate the right angle and go directly across the triangle, there's the hypotenuse. So there is a formula that you can use to calculate to see, one, if you've got a right triangle, and two, if you do have a right triangle, find a missing measurement or a missing side length. So the formula that we use is a squared plus b squared equals c squared. And the nice thing is with this, you do not have to memorize this formula. The formula for you is going to be given on your formula sheet. A to the second power plus b to the second power equals c to the second power. And the last thing that we have are what are called Pythagorean triples. And those are simply numbers that prove the theorem. In other words, they're right triangles. They're measurements of right triangles. So an example of a Pythagorean theorem would be a 3, 4, 5 triangle, because 3 to the second plus 4 to the second equals 5 to the second power. 3 squared is 9. 4 squared is 16, and 9 plus 16 gives you 25. So that would be a right triangle or a Pythagorean triple. The last thing we're going to do today is, after you find the Pythagorean triple, and there is a way that you can use the formula to find a missing side length. So the first thing we're going to do is we're going to find the hypotenuse. So you're going to use your formula, a squared plus b squared equals c squared. Then, based on either the word problem or in this case the drawing, you're going to replace your variables. Now remember, A and B are interchangeable. For today, I'm going to say that A is 9 and B is 12. So I'll plug those in. 9 squared plus 12 squared equals c squared. I'm trying to find out how long the hypotenuse is. So then I'll square those. 9 squared is 81. 12 squared is 144. I will add those together. I'm going to sum them. So that's how many squares would be coming off of the distance of the hypotenuse. I want to know what the distance is from the top of the triangle down to this corner here, just that side length. And in order to do that, I take the square root. So I would take the square root of 225. And the square root of 225 is 15. So if I were using a map and I wanted to find the distance from, I don't know, Fishersville up here to Verona down here, and it made a triangle on a map, a right triangle, then I could figure out that it's about 15 miles. Okay, another thing that we're going to have to do is to find the measurement of a leg. So this time we know the hypotenuse in one of the legs, and we've got to find the other one. So you still write your formula. You replace your variables. This time we don't know A, we don't know a leg, but we know the other leg is 5, so I'll put 5 squared. And then I know the hypotenuse is 10. I'll square everything just like I did before. 5 squared is 25, and 10 squared is 100. Now this time, I'm finding a shorter side. And if I'm finding a shorter side, that means it's got to be less than this 10 right here. So I know that 1 I need to subtract. Another way that I know that I need to subtract is given the equation. I am adding 25, so the opposite of adding 25 would be to subtract 25 from both sides. And when I do that, I'm left with a squared equals 100 minus 25, as you guys know, is 75. And then just like I did to find the hypotenuse, I need to take the square root to find the distance from this point to this point over here. So I'm going to take the square root of a squared is a, and the square root of 75 is actually an irrational number, so I'm going to have to round to 8 7/10.